Hi dear students, today we are going to discuss third chapter electrochemistry from 12th class. Actually in this chapter there are two units, electrochemistry and chemical kinetics. First let us start with electrochemistry. What is electrochemistry? Is a branch of physical chemistry which deals with electrical energy and chemical changes during redox reactions. In this class, we are going to discuss what are electrochemical cells, what is electrode potential and measurement of electrode potentials. So without wasting time, let us start our discussion. First, what are electrochemical cells? Electrochemical cells. Electrochemical cells, or these are also called galvanic cells. Galvanic cell, electrochemical cell or galvanic cell. So very simple, electrochemical cells or galvanic cells are the devices which converts chemical energy into electrical energy during a chemical reaction. Okay, I'll write. See here, galvanic cells are the devices which converts chemical energy into electrical energy during spontaneous redox reactions. So best example for galvanic cells are Daniell cells. Daniell cell. So let us discuss construction and working of Daniell cell. Here Daniell cell or galvanic cell consists of two compartments. The first compartment or first is also called half cell. It is filled with zinc sulfate solution, ZnSO4 solution. ZnSO4 solution means ZnSO4 salt dissolved in water. So it consists of a huge number of Zn plus 2 ions and SO4 minus 2 ions. Aqueous Zn plus 2 ions and aqueous SO4 minus 2 ions. Similarly, the second compartment or second cell, half cell, consists of copper sulfate solution, CuSO4 solution. It consists of a huge number of Cu plus 2 ions as well as SO4 minus 2 ions. Here these solutions are collectively called as electrolytes. Here two electrolytes we have used. Electrolyte. Here two electrolytes we have used, and in the first container in which ZnSO4 solution is there, one zinc rod is placed. Zinc rod is placed in the first container, and second container in which copper sulfate solution is there, here copper rod is placed. This zinc rod and copper rod both are connected by a external metallic wire and through a voltmeter. And both the electrolytic solutions are connected with a U-shaped glass tube. This is called salt bridge. Now this is zinc rod, this one is copper rod. Here zinc rod acts as anode. It is given negative charge. It is given negative symbol, and copper rod acts as cathode. It is given positive symbol. So this is the overall construction. Here these are called electrodes. There are two electrodes, anode and cathode. This is a brief construction of galvanic. Let us discuss once again. Galvanic cell consists of two cells or two vessels. In the first vessel, zinc sulfate solution is taken. The zinc sulfate solution consists of a huge number of zinc ions, Zn plus 2 ions as well as SO4 minus 2 ions. Similarly, the second container is filled with copper sulfate solution, which consists of huge number of copper ions as well as sulfate ions. These two are collectively called as electrolytes. And in the first container in which zinc sulfate solution is present, zinc rod is placed, and in the second container in which copper sulfate solution is present, copper rod is placed. Here zinc rod acts as anode, which is given negative symbol. Copper rod acts as cathode, is given positive symbol. Here anode and cathode both are connected by a metallic wire, external metallic wire, through a voltmeter. This is a voltmeter. Now when switch is on, electrons move from anode to cathode. Electrons flow from anode to cathode. Current flows in the opposite direction. Current flows from cathode to anode. Current flows in opposite direction. This is the brief construction of galvanic cell. And in galvanic cell, oxidation takes place at anode. Oxidation reaction takes place at anode. Now let us discuss different reactions taking place at anodic compartment as well as cathodic compartment. Actually, this is the combination of two half cells. This is called first half cell or anodic compartment. This is second half cell. This is cathodic compartment. Both are collectively called as a galvanic cell. Right. Let us see what are the reactions taking place at anode and cathode. At anode, oxidation takes place. At anode, oxidation takes place. Here at anode, listen carefully, zinc rod is dipped in zinc sulfate solution. Zinc rod consists of a huge number of zinc metal atoms. Okay? Zinc rod consists of a huge number of zinc metal atoms. When zinc rod is dipped in a zinc sulfate solution, then some of the zinc metal atoms from the zinc rod loses electrons and dissolve into the solution. That means some of the zinc metal atoms loses electrons and converted to Zn plus 2 ions and they dissolve into the solution. That means they become aqueous Zn plus 2 solution, aqueous Zn plus 2 ions and 2 electrons. What are the electrons lost by these zinc metal atoms? Move through this external wire to the cathode. Here in cathodic compartment, there are huge number of copper plus 2, Cu plus 2 ions inside the solution. Whenever these electrons moving to the cathode, then these Cu plus 2 ions are attracted by this negatively charged electrons, then Cu plus 2 aqueous ions of cathodic compartment attracted by the electrons entering into the cathode, then it is converted to Cu. This reaction takes place at cathode. This reaction takes place at cathode. Right. So first one, in first case, the loss of electron is taking place. So this part is called oxidation reaction. This is an oxidation reaction because loss of electron is taking place. Here oxidation number of zinc is 0. Here the oxidation number of zinc is plus 2. There is an increase in the oxidation state. Here in the second case, copper is undergoing reduction. How can we say it is reduction? Here addition of electrons is taking place. Cu plus 2 gaining 2 electrons and converted to Cu. This is a reduction reaction. Here oxidation state of copper is plus 2, whereas in product state it is 0. There is a decrease in oxidation number. So it is a reduction reaction. Now come to overall reaction. Overall cell reaction will be, so here 2 electrons get cancelled. So in the reactant side, zinc and Cu plus 2 ions are there. So Zn plus Cu plus 2, this aqueous, this is in solid state, gives Zn plus 2 aqueous ions and Cu, Zn plus 2 plus Cu. This is a overall reaction of galvanic cell. So this is the overall reaction, and if you observe this reaction, you can easily understand that this is a redox reaction. This is a redox reaction. How can we say this is a redox reaction? What does it mean, redox? Redox means reduction and oxidation. If both the process takes place in the same reaction, such reactions are called redox reactions. Here zinc is undergoing oxidation. Here the oxidation number of zinc is 0. Here plus 2. Increase in oxidation number is oxidation. So this is oxidation part. And Cu plus 2, oxidation number of copper is here plus 2. Here oxidation number of copper is 0. Here decrease in oxidation number is reduction. So reduction is taking place. So since both the process are taking place in the same reaction, it is called a redox reaction. During this redox process, there will be some free energy changes and chemical free energy changes. So during this, chemical energy is converted into electrical energy. So that's how a galvanic cell works. Now what is the purpose of using salt bridge here? What is salt bridge? Actually the salt bridge is a U-shaped glass tube. Salt bridge is a U-shaped glass tube which is filled with some agar gel, some jelly like compound, agar gel, and it is mixed with potassium chloride or potassium nitrate like electrolytes. The purpose of using salt bridge is it maintains the electrical neutrality of electrolytic solutions. It maintains the electrical neutrality, and next it prevents the solution from junction potential, liquid junction potential. Now dear students, you may get one doubt. So why electrons are moving from anode to cathode? Why not from cathode to anode? Or simply, why electrons are moving from zinc electrode to copper electrode? Why not from copper electrode to zinc electrode? So that we will discuss now. So to understand that, we have to know what is electrode potential, how it can be obtained. Okay, let us move on to discuss electrode potential. What is electrode potential? Electrode potential, right. And let us consider the first half of the cell, that is zinc rod is placed in zinc sulfate solution. This is zinc rod, this one is ZnSO4 solution. ZnSO4 solution consists of a large number of Zn plus 2 ions as well as SO4 minus 2 ions. Zinc rod consists of a large number of zinc atoms, zinc neutral atoms. When zinc neutral atoms are in contact with Zn plus 2 ions, there exists a potential difference. Do you understand? Okay, once again I will tell. Here zinc atoms have their own potential and Zn plus 2 ions of the solution have their own potential. Zinc rod has its own potential. Zn plus 2 ions have their own potential. When both are in contact with each other, there exists some potential difference. There exists some potential difference between zinc metal atoms and zinc ions. That potential difference is called electrode potential of zinc. Right? Then what is the definition of electrode potential? Electrode potential is nothing but the potential difference developed between electrode and electrolyte. Electrode and electrolyte. So very simple, dear students. So electrode potential is the potential difference developed between electrode and electrolyte. Now different electrodes have different electrode potentials. Some electrodes have more potential to lose electrons. Some electrodes have more potential to gain electrons. The electrode which has more potential to lose electrons act as anode. The electrode which is having more potential to gain electrons act as cathode. If any electrode have more tendency to lose electrons is called oxidation potential. So EOP, oxidation potential. If any electrode have more potential, more tendency to gain electrons, then it is called reduction potential, ERP. So in the present case, which one is having more oxidation potential? Obviously, zinc rod is having more oxidation potential because it is having more tendency to lose electrons. And which is having more reduction potential? Yes, copper is having more reduction potential because it is having the tendency to gain electrons. But dear students, you should note that these tendencies may change if we change the metals here. For example, instead of zinc and copper, if I use copper and silver, in such case, silver acts as, here let it be AgNO3 or AgSO4 solution. This is CuSO4 solution. This is copper rod placed in copper sulfate solution. Silver rod is placed in silver nitrate solution. Both are connected. This is salt bridge. Here copper. Now, if you observe here I have written copper in anodic side, whereas silver in cathodic side. What is the reason? The reason is among copper and silver, copper have more tendency to lose electrons when it is connected with a silver metal rod. Whereas when copper is connected with zinc, then copper have more tendency to gain electron. That means the tendencies of losing electrons or gaining electrons depends on the other electrode. That means here it is electrode potential is a relative tendency, not is an individual tendency. So it depends on the relative tendency. Right. Now let us discuss what is cell potential. Cell potential. How to determine cell potential? There is a simple formula to determine cell potential, that is E cell is equal to potential of cathode minus potential of anode. Potential of cathode minus potential of anode. Just for example, in the previous case we have taken zinc as anode, copper as cathode. The electrode potential, standard electrode potential of zinc is minus 0.76 volts, and the standard electrode potential of copper is plus 0.34 volts. These are the standard values, known values. And from this, what is the cell? From this, we can determine the cell potential, that is E cell is equal to cathodic potential minus anodic potential. What is cathode here? Copper. So plus 0.34 volts minus anodic potential. Which one is used as anode in the previous case? Zinc is used as anode, minus 0.76 volts. So that is equal to, here minus of minus becomes plus, if we add these two becomes 1.10 volts. This is the cell potential. Okay, cell potential can be easily determined if you know half cell potentials. Generally in board exams, 2 half cell potentials will be given and you are asked to find total cell potential. Then you can easily calculate by using this formula. Some of the students are confusing that which one is anodic potential, which one is cathodic potentials, how to know. It's very simple. The one which is higher in value is cathodic potential, the one which is lower in value is anodic potential. For example, here among the given two values, copper is having higher value, that is plus 0.34, so it is cathodic potential, and this one is having minus 0.76 volts, so it is anodic potential. Otherwise the formula can be modified as cell potential E cell is equal to higher potential value minus lower value. Higher value minus lower value. That's very simple. And if you see galvanic cell, just briefly I am drawing here. Once again, zinc rod, copper rod connected with external wire. This is salt bridge. This is zinc sulfate solution. This is copper sulfate solution. And this is zinc rod, copper. This one is anode. This one is cathode. Right? Here anode is written on left hand side, cathode is written right hand side. Here anode is written left hand side, cathode is in the right hand side. So the same formula can be written as E cell is equal to E right minus E left. This is also one of the formulas. Right. This is how we can determine cell potential. If cell potential is determined at 1 molar concentration of electrolyte, then it is called standard cell potential, and it is represented by E naught cell. That means whatever the electrolytic solutions we have taken, if their concentrations are equal to 1 molar, then whatever the cell potential we got, it is called standard cell potential. Right? Now let us move on to how to represent a cell. Now here it is it becomes very difficult to represent the cell diagram every time, isn't it? So that's why there is a simple IUPAC representation of cell. Cell can be represented very easily by following IUPAC rules. Here, if you observe this cell, galvanic cell, here zinc is the anode, electrolytic solution, salt bridge, and electrolytic solution, copper sulfate, and electrode. That means electrode, electrolytic solution, salt bridge, electrolytic solution, electrode. So first electrode, zinc, it is in contact with zinc sulfate solution, salt bridge, copper sulfate solution, copper. Okay, I'll explain. Anode should be written at extreme left, cathode should be written at extreme right. And anode is in contact with this electrolytic solution, so both are separated by a vertical line. Next, cathode is in contact with its electrolytic solution, and these two are separated by a vertical line. Now this is half cell, this is another half cell. Both the half cells are connected by a salt bridge, and it is represented by two parallel vertical lines. This is a simple representation. Since anode is having negative charge, cathode is having positive charge, we can mention their symbols also. So very simple representation. If any cell is given, you can represent like this. This representation can also be written in a simple manner like Zn bar, Zn plus 2, aqueous solution, two parallel arrows, Cu plus 2, aqueous Cu plus 2, bar Cu, solid plus, this minus. This can also be written like this. And from this, if you are asked to write complete cell reaction, it's very simple to write complete cell reaction. See, let us take this is 1, 2, 3, 4. Now 1 and 3 is written in the reactant side, Zn plus Cu plus 2 use, and 2 and 4 should be written in the product side, that is Zn plus 2 plus Cu. Right? This reaction we already got during our galvanic cell overall reaction, isn't it? This is the complete cell reaction. If you are given any cell representation, from cell representation you can easily write cell reaction.